download the files from the link in the descriptions of the video, and then attempt to make this mechanism work. In the input grapher for this shaft, set it so that the shaft rotates in one direction, then pauses, and then rotates in the opposite direction. Your washing machine might have a transmission similar to this, where the motor turns one shaft and then you get intermittent motion from a second shaft, say the drum of the washer. I've made these files available in a link in the description of the video. Download the files, and they're in step format, and go ahead and open those and then save the files. And I have 3 sub-assemblies here, so if I drag this, I see I have the frame sub-assembly, which is grounded, the cross sub-assembly, and the rotor sub-assembly. Go into the dynamic simulation environment. So I'll go to environments, dynamic simulation, and I'll hit C for constraints, and I'll go ahead and put an insert constraint between this circle on the bottom of the cross and this circle on the top of the bearing, and I'll say OK to that. Now when I do that, I see that it automatically converted that to a revolution joint, which is what I expected, and if I drag this, I see that it has 1 degree of freedom, the revolution. I'll do the same thing with this part, so I'll do constraint, C for constraint, I'll do insert, I'll select the top of that bushing, and I'll select the bottom of this, and I'll say OK to that. And then if I drag this, I see that with this I have 1 degree of freedom. It's a revolution joint. Let's go back to the assembly environment for a minute, and I want to set these up so that they're lined up in some home position. So I'm going to expand the frame and the cross, and I'll go to the origin folder, and I'll find a plane that goes through. So it looks like the XZ plane would be a good one to use, and then on the cross I'll do the XZ on that as well. So I'll do C for constraint, and I'll put it on flush. I'm going to do XZ of the cross and XZ of the frame. And I'm going to name that home position 1, and then I like to put a note in here, so I'll say dash suppress this. Alright, then I'll close down the cross and I'll expand the rotor, and I'll find the XZ plane of the rotor, and actually I see that that plane isn't going through this pin, which is what I would like, but I see that if I rotate that around, unfortunately whoever made this assembly, they didn't line the pin up on the rotor, but I'll just go ahead and do the XZ on this. I'll do flush to the XZ plane on the frame, and let's put that on mate instead of flush. I don't want this over here where it's interfering, and I'm going to call this home position 2, and I'll put in my note to suppress this. Okay, so as this comes around, the pin is going to enter the slot and move this. When the pin isn't in that slot though, we don't want this cross to move. There is a slight little bit of clearance between the cross and this cylinder, and then if we measure the pin and measure this distance, there should be a little bit of clearance between the slot and the pin. So let's go to the inspection tab, and I'm going to do measure, and I'll put it to precision to all decimals, and I'm going to measure this distance from here to here, and we see that that is 0.014 meters, and we might change these units. I'll do that in a second here. 0.014, and then if I measure this, we see that that's 0.0138, so there is a little bit of clearance. Now if I measured it up here, this part doesn't come in contact with the slot, this roller does, but if I measured it, I see that that's the same size as the slot, but that isn't what comes in contact, so don't get misled by the size of this washer. So let's go ahead and change our document unit. So I'll go to Tools, Document Settings, and under Units I'm going to set this to millimeters, and for the angles I'll set degrees, time is under seconds, and for the mass I'll do as kilograms. Alright, I could put a contact set between this part and this part, or these sub-assemblies, in the assembly environment. So I'll go ahead and do that. I'll do contact, and I'll do contact on this one as well. And then remember, we need to suppress those two home positions. Those are just our starting positions. So I'll suppress this and suppress this on both of those. And then I'll go to the inspection tab and I'll activate the contact solver. So as I drag this around, when it comes in contact, it does push it. Conversely, if I try to push this part, when it comes in contact with the cylinder, it can't move, or it only moves that slight amount of the clearance. If we want to drive this in the assembly environment, we can put an angle constraint between this component and a plane going through either the assembly top level or through the frame, and then drive that angle constraint. I think we understand how to do that, so I'm going to set this back to my home positions. So I'll unsuppress those and then resuppress these as my home position so that I know that everybody's starting in the same location. I'll turn off the contact solver. It's important to turn this off because this is computationally expensive. It will slow everything down. And so once I've verified my contact, I'll go back to dynamic simulation. I have my 2 revolution joints. So I need to define a constraint between this cylinder and the part to keep the cross from intersecting or interfering with the cylinder. So I'm going to do that as a 2D contact since these stay in the same plane. And so I'll do 2D contact, and it asks me to select a curve. I'm going to select this face on top, and then for the curve on this part, I need to get the curve on the bottom of the cross because this slot is over here, further open up here for clearance around this washer, but the minimum distance is down here. And actually it doesn't matter where you pick this edge. Even though it only shows one edge is highlighted, it picked the entire edge, bottom edge of that cross. I'll say apply to that, and then I need to do the same thing for the pin. So I'll select this circle on the bottom of this pin, and then I will select one of these curves on the edge of the bottom of the cross, and I'll say OK to that. I'm going to expand the contact joints, and I'm going to select both of these 2D contacts. I'm going to right click and go to properties, and then I'm going to put this restitution value down to a small number. We don't want these parts bouncing around a lot, and so I might even put that at 0. I think I'll put it at 0.1. I'll leave the friction value where it is. And so I was able to change both of those at the same time by selecting them both with the shift key and make those changes to both at the same time. All right, then I'm going to put a motor to drive this shaft is our input shaft, and so I will do that by driving the revolution joint. Now we could put a torque on here instead to drive this motor. I'm going to find the revolution joint for that shaft, and I'll go to properties and 1 degree of freedom revolution. I'll go to edit and pose motion, enable it, and I'm going to do a constant value of 360 degrees. Of course, if we use the input grapher, we could tell it to go in one direction. We could speed it up, slow it down, do whatever motion that we need with the input grapher. I'll then play this, and we see it goes around and contacts. And so let's increase the time period, and so I'm going to say let's do this for 10 seconds, and I'm going to do 1,000 calculations. I might increase that number of calculations. Alright, so we see how that moves. I'll rewind this. If I drag this, we see that it moves as we would expect it. I will show the output grapher, and I'm going to go to the standard joints and find the joint for the input, and I've already found that as revolution 2, and if I show the velocity of that, it is a constant value, the 360 degrees per second. If I show the velocity of the cross, we see that it increases and decreases. And we can click inside this graph and zoom in on the graph, or we can change the size of the graph. And I might be interested in the acceleration of the cross rather than the velocity. We can see how that acceleration increases in one direction and then the other direction. So the challenge that I have for you is to go to the properties of the input revolution joint and do an input grapher where it is speeding up, slowing down, dwell, changing to the opposite direction, so that it revolves clockwise for a period of time and then counterclockwise for a period of time.